Preparing for a technology interviews at PwC interview? You've reached Candy Mentor, and this video is for you. We'll walk through 20 key questions you're likely to face. For each question you'll see a sample answer followed by the key points to cover. Subscribe, like, and share, and drop a topic request in the comments. Question 1. Tell me about yourself and why you want to join PwC as an associate consultant. I am a software-focused graduate with experience building applications using Java, SQL, and cloud services. My projects strengthened my problem-solving, teamwork, and debugging skills. I am interested in PwC because the role combines technology delivery with business problem-solving and client interaction. PwC's consulting environment would expose me to varied industries and structured learning. I can contribute through solid fundamentals, adaptability, and clear communication while developing into a dependable technology consultant. While answering, connect your education, technical skills, projects, communication ability, consulting interest, understanding of PwC, and motivation to solve practical client problems collaboratively. Question 2. Walk me through a technical project you are most proud of. I built a service booking application that allowed users to search providers, reserve appointments, and receive confirmations. I designed REST endpoints, modeled users and bookings in PostgreSQL, and added validation to prevent overlapping reservations. My main challenge was maintaining consistency when two users selected the same slot, so I used transactions and database constraints. I tested both API behavior and failure cases. The project taught me to connect clean design decisions with user outcomes. Make sure to cover the problem, users, architecture, your individual contribution, technology choices, challenges, testing, measurable results, and what you would improve with more time. Question 3. How would you explain object-oriented programming to a non-technical client? I would compare object-oriented programming to organizing a business around responsible teams. A class defines a blueprint, while an object is a working instance, such as one customer account. Encapsulation keeps internal details protected, abstraction exposes only useful actions, inheritance reuses shared behavior, and polymorphism lets different objects respond appropriately to the same request. These ideas make software easier to extend because responsibilities are separated and changes remain localized. In your answer, talk about objects, classes, encapsulation, inheritance, polymorphism, abstraction, practical analogies, maintainability, and how these principles support change in business applications. Question 4. What is the difference between an interface and an abstract class? An interface primarily defines a contract. Classes agree to provide certain operations, allowing unrelated types to be treated consistently. An abstract class can define that contract while also sharing implementation, state, constructors, and protected helpers. I use an interface when flexibility and interchangeable behavior matter, such as multiple payment providers. I choose an abstract class when subclasses genuinely share a stable foundation. The best choice depends on cohesion, not merely code reuse. Be sure to mention contracts, shared implementation, state, constructors, multiple inheritance limitations, language-specific behavior, and how you would choose between the two in a maintainable design. Question 5. How would you find duplicate values in an array efficiently? For an unsorted array, I would scan once while storing previously seen values in a hash set. If a value already exists, I report it as a duplicate, otherwise, I insert it. This gives average O, n, time and O, n, additional space. If memory is limited, I could sort the array first and compare adjacent elements, requiring O, n log n, time. I would clarify whether the output needs unique duplicates or frequencies. While answering, explain the straightforward nested loop approach, hash set optimization, time and space complexity, sorting alternative, duplicate frequency requirements, and assumptions about input constraints. Question 6. What is the difference between a process and a thread? A process is an independent running program with its own address space and operating system resources. A thread is a smaller execution unit within a process, sharing memory and resources with sibling threads. Processes provide stronger isolation but cost more to create and communicate between. Threads are lighter and useful for concurrent tasks, though shared state introduces race conditions. I would use synchronization carefully and choose processes when fault isolation is critical. Make sure to cover memory isolation, resource sharing, creation cost, context switching, concurrency, synchronization risks, and examples where processes or threads are more appropriate. Question 7. What is a deadlock, and how can it be prevented? A deadlock occurs when tasks wait indefinitely for resources held by one another. The classic conditions are mutual exclusion, hold and wait, no preemption, and circular wait. I prevent it by acquiring locks in a consistent global order, keeping critical sections short, avoiding unnecessary nested locks, and using timeouts where appropriate. In databases, transactions can be aborted and retried. Monitoring and deadlock detection remain important because prevention alone may not cover every path. In your answer, identify mutual exclusion, hold and wait, no preemption, circular wait, prevention techniques, lock ordering, timeouts, detection, and recovery strategies. Question 8. Explain normalization in relational databases and its practical benefits. Normalization organizes data so each fact is stored in an appropriate place, reducing duplication and inconsistent updates. First, normal form removes repeating groups, second addresses partial dependencies, and third removes dependencies on non-key attributes. For example, customer details should not be repeated across every order row. Normalization improves integrity, although excessive decomposition can require expensive joins. I would begin with a normalized model and denormalize only after measuring a real performance need. Focus on data redundancy, update anomalies, first through third normal forms, functional dependencies, integrity, joins, and when controlled denormalization may improve performance. Question 9. What is the difference between inner join and left join in SQL? An inner join returns only rows with matching keys in both tables. A left join returns every row from the left table and matching data from the right, using null when no match exists. For example, an inner join finds customers with orders, while a left join also includes customers who have never ordered. I would carefully place filters because a condition on the right table in where can unintentionally turn a left join into inner join behavior. Be sure to explain matching rows, unmatched records, null values, filtering behavior, business examples, join keys, and how where conditions can unintentionally change outer join results. Question 10. How would you optimize a slow SQL query? I would first reproduce the issue and inspect the execution plan rather than guessing. I would check for full table scans, inefficient joins, missing or low selectivity indexes, unnecessary columns, functions on indexed fields, and excessive result sets. Then I would test a focused change, refresh statistics if needed, and compare latency under realistic volume. I would also investigate blocking and connection behavior. Optimization must preserve correctness and be validated through measurable benchmarks. While answering, cover execution plans, indexes, selectivity, joins, filtering, returned columns, statistics, pagination, locking, query frequency, and validating improvements with production-like data. Question 11. What are REST APIs, and what makes an API well-designed? A REST API exposes resources through standard HTTP operations. A well-designed API uses meaningful URLs, appropriate methods such as get, post, put, and delete, consistent status codes, clear errors, validation, and predictable response formats. It remains stateless so each request contains the required context. I would also design authentication, pagination, rate limiting, versioning, and ID impotency deliberately. Good documentation and backward compatibility matter because APIs become contracts between independent teams. Mention resources, HTTP methods, status codes, statelessness, validation, authentication, pagination, versioning, ID impotency, error formats, documentation, and backward compatibility. Question 12. How would you secure a web application handling customer data? I would apply defense in depth. Authentication should use strong credential handling or an established identity provider, while authorization must enforce least privilege on every sensitive action. I would encrypt data in transit and at rest, validate and encode input, protect sessions, store secrets outside source code, and use parameterized queries. I would log security events without exposing personal data, patch dependencies, scan regularly, and design retention policies around privacy requirements. In your answer, discuss authentication, authorization, encryption, input validation, secure sessions, secrets management, logging, least privilege, dependency updates, privacy, and security testing. Question 13. What is the difference between authentication and authorization? Authentication answers, who are you? Authorization answers, what are you allowed to do? For example, a user authenticates with credentials or a single sign-on token, then authorization determines whether that user can view reports or approve payments. I would enforce authorization on the server for every protected resource, using roles or finer-grained permissions and least privilege. A valid token proves identity, but it must never automatically grant unrestricted access. Make sure to distinguish identity verification from permission checks, explain tokens and roles, mention least privilege, session handling, examples, and why authorization must be enforced server-side. Question 14. Explain cloud computing and compare IaaS, PaaS, and SaaS. Cloud computing provides computing resources over the internet with elastic usage and usually pay-as-you-go pricing. IaaS offers virtual machines, networks, and storage, giving teams control but requiring more operations work. PaaS manages the runtime and infrastructure so developers focus on applications. SaaS delivers a complete product, such as a business collaboration tool. I would choose based on required control, internal skills, compliance, speed, and the application's operational responsibilities. Focus on shared responsibility, control versus convenience, infrastructure examples, managed platforms, complete applications, scalability, cost, security, and suitable use cases. Question 15. How would you design a scalable document upload service for a client? I would store files in durable object storage rather than application servers, keeping metadata, ownership, status, and permissions in a database. Clients could receive short-lived upload URLs from an authenticated API, reducing backend bandwidth. An asynchronous queue would trigger virus scanning, format validation, and optional extraction. I would enforce size and type limits, encrypt data, audit access, monitor failures, and design retries carefully. Regulatory requirements would influence retention and regional storage. Be sure to discuss requirements, object storage, metadata, APIs, authentication, validation, asynchronous processing, virus scanning, quotas, monitoring, reliability, and protection of sensitive documents. Question 16. What is the purpose of CCD, and how would you implement it? CCD reduces the risk and effort of releasing software. On each change, a pipeline would compile the application, run unit and integration tests, scan dependencies, package an immutable artifact, and publish results for review. Deployment would progress through controlled environments using infrastructure as code, health checks, approvals where necessary, and automated rollback. I would use canary or blue-green releases for riskier changes and monitor business and technical metrics afterward. In your answer, cover automated builds, tests, code review, artifact management, deployment environments, approvals, rollback, infrastructure automation, security checks, and monitoring after release. Question 17. How do you test software effectively? I use a layered strategy. Unit tests verify focused business logic quickly, integration tests validate databases and external boundaries, and end-to-end tests confirm critical user journeys. I add contract tests for service interactions and targeted performance or security tests for higher risk areas. Tests should be deterministic, readable, and run automatically in C. I prioritize coverage by business impact and failure risk rather than chasing a percentage alone. While answering, distinguish unit, integration, system, acceptance, regression, performance, and security testing. Mention risk-based prioritization, test data, automation, and maintainability. Question 18. Describe a time you faced a disagreement in a team. During a project, a teammate preferred adding a framework while I favored a smaller library to reduce complexity. Instead of arguing from preference, we listed requirements, maintenance concerns, delivery time, and team familiarity. We built a small comparison and reviewed the results together. We chose the simpler option for the current scope, while documenting how the framework could be introduced later. The discussion improved trust and helped us deliver on schedule. Make sure to use a concise situation task-action result structure, demonstrate listening, evidence-based reasoning, compromise, accountability, communication, and a measurable or observable outcome. Question 19. How would you handle a client who cannot clearly define their requirements? I would avoid jumping directly into implementation. First, I would identify the business outcome, users, constraints, and decision-makers through focused questions and active listening. I would document assumptions, separate essential requirements from preferences, and use a simple prototype or process diagram to expose misunderstandings. Then I would agree on priorities and measurable acceptance criteria. Short feedback cycles help the client refine needs while giving the delivery team a controlled, shared direction. Focus on active listening, stakeholder mapping, business outcomes, clarifying questions, assumptions, prototypes, prioritization, acceptance criteria, documentation, and iterative validation. Question 20. Why should PwC select you for a technology associate consultant role? PwC should select me because I combine practical technical foundations with a consulting mindset. I can analyze problems systematically, write maintainable code, work with databases and APIs, and explain technical decisions clearly to different audiences. In projects, I have taken ownership, learned unfamiliar tools quickly, and responded constructively to feedback. I also value integrity and collaboration, which are essential when working with client data and delivering solutions that people can trust. In your answer, connect technical fundamentals, structured problem solving, learning agility, teamwork, communication, ownership, client orientation, integrity, and specific evidence from projects or experience. If you are still with us, congratulations, you are much ahead of the rest and serious about preparing for your interview. We hope we were able to add value to your preparation and create some helpful content. Do not forget to like and share this video. Your small act can do great things for us.